Hi everyone, and welcome back from the break. My name's Rob Neff, this is Praveen Kumsagi, and this is Hugh Ma. We're on the Flex Cloud Labs team. So what we do is we take our Flex rack scale platforms and we integrate them with cloud software that comes from our various partners. So, as you can see on the slide, we can use this one right here. As was presented in the previous presentation, we work with various stacks. So in this case, we're going to demonstrate a Kubernetes stack that's running a Redis database. And we're going to test it using benchmarks that are driven by Ansible. But before we do that, Praveen is going to come up and talk a little bit about the Flex Bolt switch, and he's going to do a little demonstration. Praveen?
Yep. Thank you, Rob. Hello, everyone. Now we are going to do a live demo of traffic between two servers in the cage that is going through the Open19 embedded switch called Bolt. To give a quick overview of what Bolt is the Open19 rack embedded switch, which is based on Broadcom Tomahawk silicon, which has a switching capacity of 3.2 Tbps. So it has COM Express module, which is based on Intel Xeon D processor. It has 4 RJ45 management ports. It supports 16 gig of DDR4 SDRAM and has a storage space of 128 GB. It has 5 fan modules and gives N+1 redundancy, and these fan modules are hot swappable. The switch port configuration can be configured as 48 50 gig ports or 96 25 or 96 10 gig ports that is going to the server. It has 8 QSFP uplink ports that can be configured as 800 gig or 840 gig that is going to the spine switch. Now let's look at the Bolt software stack. So we can see at the bottom we have a bare metal platform Bolt. So on top of that we see a Tomahawk ASIC from Broadcom. For the embedded BMC controller we have a BMC module from ASpeed which manages the system peripherals. So we are running open source OpenBMC as the software. So we have Oni bootloader on top of that. This enables us to install the network operating system. We have Broadcom SDK. This is basically a driver for the Tomahawk. So we are currently running ICOS as our network operating system. So this is the current rack configuration. So now we are using Linux packaging to generate traffic on one of the servers, and it is going through the Bolt switch to the second server. So let's get into the console of the sending brick. We have already pre-configured the source IP address, destination IP address, and we have set the packet size to be 1500. This is the standard MTU. If you look at the UI, we can see the traffic is coming on the one on the right is the sender node, and one on the left is the receiver node. We can see a positive trend in the spike on the sender, a negative trend since it is receiving. So we are seeing a line rate over the 10 gig. Since we demonstrated the network connectivity in the cage, now I would like to hand it back to Rob to talk more about the cluster management platform. Back to you, Rob.
Thanks, Praveen. So once we go through and we validate all of the connectivity between the nodes and the rack, we turn to our software partners and our automation platform to deploy a cloud solution on top of that. In this case, we're working with Stacky to go ahead and deploy Kubernetes across the cluster. So we're also putting in an Ansible node, though, to do testing. And this is what launches the workloads, or launches the commands to start workloads. So the Ansible, so Stacky goes ahead and it deploys Kubernetes across the rack. It creates many pods, and then we take Ansible workloads and we create Redis databases and containers throughout the cluster. So we'll have hundreds of these Redis containers running, and then we'll go back to Ansible, and Hugh's written test workloads using the Yahoo Cloud Serving Benchmark to generate traffic against the Redis master, which then replicates the reads and writes and database queries to the Redis slaves. Now we're going to show you the demonstration here. Hugh is going to go to our Ansible Tower instance, and he's going to launch the job. So what this Ansible does is it SSHs into those 3 orange boxed workload servers, and it launches 3 simultaneous workloads. When those workloads are successfully launched, we can then monitor the response via the Grafana UI. So you can see this UI shows 6 of the nodes, which each have 28 cores. And you can see the CPU starts off all blue and it's idle, but then slowly the yellow indicates activity being generated. Now this benchmark takes some time to ramp up, but I think you understand the idea here. As the context switches go up and the network traffic starts to fill up to close to line rate, then we start to see bottlenecks. And that's really what Cloud Labs does, is we look at various bottlenecks, whether it's in the storage or the networking or the compute, whether we see the CPUs overutilized, whether we're running out of memory, maybe we need a faster flash drive or more flash drives, or maybe it's a software configuration issue and we work with one of our partners to tweak the configuration file that could give us much better performance without having to upgrade the hardware. So the whole goal of Cloud Labs is to get the optimum performance for the minimum price change. So that's an example of what we do with Flex, and it's all running on Open19. So next up is going to be Cole Crawford with Vapor.io. They're a partner of ours, and we use their Open DCRE software to monitor the health of our systems while we're running these workloads, including power and thermal efficiency. Thank you.